Hello everyone, my name is Alexander Zelenin.
Hello, my name is Alexey Khaletsky.
Today we start to solving problems related to arrays and I want to start with some theory about arrays itself. What is it, how it works, and like how memory it's originally used, how fast they work, and so on. Like what we can do with the array itself, arrays. So let's open some task. But for now, it's I just for background. So array is a collection of some data. If
I'm sorry, Alexander. I just want to say that this is interesting sim, so I happy to hear something about it. So let's
nice.
go.
So this is like a collection of some information, for example, the set of numbers or something like that, or set of strings or whatever. And the implementation changes with the language, but generally all the rules independent from the language itself, so all these rules applicable for any language. Uh, JavaScript, PHP, or C++ or whatever. Uh, so, first of all, we can choose like between two types of arrays in most of languages. The first type of array is array with defined length of this array. So like we have array of 10 elements and that's all. We cannot add more than 10 elements. There will be always 10 elements. And dynamic arrays, where we can add as many elements as we want. I will explain a bit later what the difference between them. In JavaScript, we have only dynamic arrays. There is, as per my understanding, there is no way to define array with some size, at least right now. The idea behind the dynamic arrays is when we reach capacity of this array, we increase, we're creating a new array with higher size and copy all elements from the first array to the second one and then add new value. So it like take some time, but it happens only not so often. So it not so do not waste too much resources for this extending array. This happens because array should be on the same place in memory physically. Have you used torrents or something like that in past?
Yes. Yes, I did.
Maybe you hear about hashing algorithms, about hashing something. When we have
Yes, yes, I did. But should you explain it for our viewers?
yes, with the hashing algorithm, we can represent some big amount of information with a small string. For example, if I remember properly, for torrents for MD5, it's 44 symbols or 40 symbols. Sorry, but okay, it's not matter too much right now. But generally, like any file can be represented as this amount of symbols. But here is the problem. Different files, since we have like this only 40 symbols, and we have unlimited amount of other files. For example, if we will try to code some text files, which will have, for example, 50 symbols, and we will have files with like all possible combination of these symbols. Of course, some of them will lead to the same string. So, like, some of the files will have the same hash string. That's clear?
Mm-hmm.
I will go back a bit to arrays and explain how it works. So, array is very efficient when we try to find a value. For example, if we ask to get value of the second element, it like instantly send to us this information. And it consume like very low CPU and so on. How does it work? Every key in array is like hash for some data. And when the computer go to find some information, it uses this hash to find the cell with this information. And in most of languages, array keys is like integers. So we are limited to integer value for the keys. But it's possible to have more values and then it will be a bit slower. But okay. So for getting information from array, we have complexity of 1 because of this hashing thing. So it's very efficient, very fast, and so on. But when we try to insert data, generally it's also 1. For fixed size array, it's always 1. And for dynamic size array, it's also 1, but need to explain a bit, like what is happening and why it's 1 if we do a lot of additional steps. When we like create a new array, put all the information from old one to new one, and so on. What happens when we reach the maximum size of our array? We put all old elements to the new array with usually 2 times larger than previous one. It also depends on the language, but generally it's 2 times larger. So for example, if we start with array of 4 elements, when we reach 4 elements, it will create array of 8 elements, then of 16 elements, and so on. So when we reach 4 elements, we create array of 8 elements and copy each of these 4 elements to new array. So it's looks like it took n time, so it depends on the length of array. But this happens very rarely. Like it happens the size of array divided by 2, by 4, by 8, and so on. So if we will sum all of this, it will be like still less than 1. So by the nature, since it happens very rarely, we have the complexity of 1 for this operation. And a bit of other things. If we have big array and we want to remove one element from sum of part, for example, we want to remove the first element of array, what will happen and how we can do this? Generally, we remove first element and then move all of other elements to the left. So like for one step. And it consumes n operations since we need to move like every element. So it's very consuming. But if we remove last element from array, it just took 1 since it's last element and it's very easy to remove. For now, it's clear?
Mm-hmm.
Okay. I think that's enough for theory for now, and we can go to the task itself.
Let's resolve some problem. Hey.
Yeah. So we have left rotation problem. I hope that task was on the screen for enough time, so all who want was able to read it already. If you don't read it, so please read.
Make a pause for our video, read it, and then we come back to us.
Yep. So, the idea that we got some array, initial array, and then we need to move like all elements for some amount of like we need to move all elements, for example, for 4 times. So in the end, we will have like 5, 1, 2, 3, 4. So in this example, we have, let me see what's the input format here. Okay, and integers. So we have minimum 1 element, maximum 100,000 elements. How you think we can solve this?
Well, this looks more, more abstractive than the other one.
We
Problems that
can
we solved already have solved.
we can like find some sample for this task. For example, you have 5 boxes and you need to rearrange them in some order. So here you see like 5 boxes, and someone asks you to put the first box to the last position, like move to the right, and repeat this operation some amount of times, for example 4 times, and to get some result. But he don't worry about the intermediate steps. So
if we use it in the real life, I just take the first box, put it up, move in the end of как очередь по-английски?
Q.
In the end of Q and put it down.
Okay.
And make it 5 times with another 4 box.
Okay.
And made it another 4 times. 4 times.
Okay. And what if someone will ask you to rotate it 5 times?
Well, if he pay me for this, I'll do it.
Nice. But he will pay you for result and not for the process itself. So we have like 5 boxes and he asks you to rotate it 5 times.
Rotate boxes or change its places?
Change its places, yes. By rotate, I mean like all of them. Like,
in one time, or we can do it in a queue.
As you want. So, like you have 5 boxes. You need to put the first box to the last position and repeat it like 5 times. Not to repeat it 5 times, but get the same result as you will get after this rotation.
Well, I check which one from this box is the first one. Take it and move it to the end. Then check.
But the idea, if you will need to perform this operation 5 times, that in the end, in the start you have 1, 2, 3, 4, 5, and in the end, after five operations, you will have 1, 2, 3, 4, 5.
So what? I don't see.
So the array.
What's your point?
My point is, if you need to do rotation equal to the amount of boxes, nothing will be changed.
Ah. So we should perform it 4 times, not 5 times. 4 times.
But if someone asks you to do this 5 times, you can just instantly tell him done. Right?
Yes.
What if he will ask you to do this 10 times?
The same position. I can say it's done.
Nice. And what if 11?
I should do it 1 time.
Okay, how you calculate it?
I just I just know how much times I need to do rotation for the same position. It's 5.
Okay.
So every 5 time I know it's 5, 10, 15, 20, 25, 30, 35. And I just know how many times I should make rotation for not be in the same position in the start.
Okay, so you got the number that left after you divide amount of boxes to amount of rotation.
Yes.
Okay, then let's think a bit like, can we understand what the position will be after we want to do everything? I mean, maybe we can do it like in one operation somehow, like in a one run. For example, instead of moving it one by one. 1 second, I was thinking that it's not applicable for the real world. Okay, I think we can start with this algorithm and then optimize it. Fine?
Okay.
The main thing that you should know is that task should be solved. It not depends is it solved optimal way or not, but it should be solved. If you not solve the task, all of other things doesn't matter. So we can start with implementing our function. It's go get 2 variables. We need to check what is it. A and D. To separated integers. D is how many times we need to rotate. So we have some simple sample input. A number of elements, a number of rotation, and elements itself. We can see that A is elements and D is rotation. So let's call it elements and let it called count for now. So the first thing that we want to do is we want to check how many times we need to perform operation, right? To divide amount of elements for for the count. We will change this value itself, and this means that we get what left from the division. So it's like if we have 11 divided by 10, it will be 1. So it's like divide by 10 and take what is left.
Why we divide by 10, not by 5?
We can divide by 5. It doesn't matter. It will be the same result exactly here. But we divide by... sorry, it should be like this. So we divide the count by the amount of elements and not... This could be some stupid error. So, and what we need to return? We need to return the array itself after we rotate all the elements. So we can make an cycle for count of times. Sorry, not count. And we will get the first element and put it to last position from our elements. So in array we have operation called pop, which return the last element. Sorry, we need to get first element. It will be on shift, I hope. Yes. Sorry, on shift is to insert. And then it will be shift. Yes. So, elements shift got the first element and remove it from array. Elements push put element to the last one to add to array. So by this operation, we get element and push it to the last position. So we got first box, put it to last position. That's all. That's all for now. And we can like run code and see what will happen. Test cases work fine. We can submit our code and take a look how it will work. It works perfectly. So we achieve higher score, everything is fine, but we want to do this in more optimal way. But before we will do this, let's count our space complexity and time complexity. Do you remember what is it?
No.
Okay, space complexity is...
Well, yes. Well, I remember what is it, but I want you to repeat it in every video, please.
Okay, so space complexity is how fast we consume memory depending on incoming variables. So if elements or count will be changed, how the memory consumptions will be changed. So it's not how memory is used exactly, but how it change over time and depending on every argument. And time complexity is how time consumption by CPU is changed depending on incoming variables. So it's the same, but for the time. For space complexity, we can see how many new variables or how many new data we have in our algorithm. We have 0 of new data, in our current algorithm, so space complexity will be 1. Like, why it's 1 if it's 0? But if we have just a number, then it's 1. Just accept it. And for time complexity, the first operation is just one-time math operation, so it's 1 for this operation. Then for push and shift, it will be a bit more complicated. Shift operation, as I explained previously, take a lot of time. So you took the first element, then move all the element. It took the element's length time. And for push is very simple. It's just 1. Okay? And we do this for in the worst case. We always should think of worst cases. In the worst case, the amount of rotation required will be 1 less than amount of the boxes. For example, if you have 100 boxes and we will need to rotate 99 times. Sounds not good, right? So we can think that this is also the cycle itself happens element length time. And combination of this will be elements length in square. Since for every element, it perform operation over all elements. Is it clear?
Yes.
And 1 we just drop since it doesn't mean anything. So for this we have elements in square, 1 again doesn't matter, and we have at the end elements length in square. So we can call it n square. So let's think how we can optimize it. For example, if we'll have this situation when you have 100 boxes and you need to rotate 99 times, what you will do?
I will rotate 99 times.
No, generally, someone asks you to do this. So how fast you? Yeah.
I don't. I think I should automate somehow.
Okay.
But here is you are the boss. So tell me, what should I do?
I want you to solve how to approach to this. So we
Yes.
have, let's get back to our problem. We have 5 boxes, 1, 2, 3, 4, 5. In the end, we want to achieve a result 5, 1, 2, 3, 4. How you can achieve this result?
I can make 4 rotations.
Okay, yes, it's one of the way, but maybe you can do it somehow better.
Yeah. I feel I feel stupid a little bit. I can make 1 rotation, just 1. I take box number 5 and move it to the start of this.
All right, great. What if?
I can take my banana and eat right now, like a treat.
What if you will need to do 3 rotation in this case and have like 4, 5, 1, 2, 3?
Well, I can make 2 rotations, just. move
Great.
5 and then 4 box. Box number 5, then box number 4 to the start of the.
Great. So the thing here that we can optimize it like 2 times. So for these worst cases, they will like never happen. So we can change the rotation. Like instead of rotate to the left, we can rotate to the right if we calculate like better. But if we will do this, our algorithm complexity will be not changed too much. We will optimize it like 2 times, so it will be like 2 divided by 2. N divided by 2, so like this. Which is better, but since we drop all constant, it will not change time complexity itself. But this approach anyway better, like it's 2 times better, we can just accept it. But on any interview, if you will try to follow this approach that doesn't change time complexity itself, no one will follow you. So it's meaningless optimization.
You just take your banana and go home.
Yes, like this. So we need to go from O(n) square complexity to O(n) complexity. And on previous problems that we tried to solve, when we go from n square, what else was changed? How it affects space complexity generally?
It's affects nothing to space complexity.
By itself, yes. Okay, the logic was too complicated in my mind, so okay, I will explain. Generally, to optimize any algorithms, you can use space, you can use memory. So, like, we can took this square from here and do like this. It's not like general rule, it's not possible to do always and so on. But in a lot of cases, it's possible to do something like that. And we have like n here and n for the cycle. If we will able to remove this line, we will able to achieve O(n) complexity, which is much better than O(n) square. And we can do this by constructing new array from the scratch. So we will create new array. And we will put all values from our old array to the new one. So how we can do this? First of all, we will do this operation elements length time, since we need to move like every element anyway. So let me remove this code. Let me remove it at all. So, and we will need to start with position of count, and then go to the start of array. So let me start to write code and I will explain. So we will start with the position of count. It's for example if 4 count -1. Since array starts with the 0, we need to start with count -1. While I less than something, we will increase I by 1. And think here that we need to do something like this. We will do a bit of math here. We'll add to elements length or count. But generally it's better to pre-calculate it. So last index like this. And inside we will put elements to our new array. So we do push from elements and we will insert element element I, but we will get what is left from division like this. So let me explain what is happens right now. Let me just check. I presume that
Well, please explain yourself. Please explain.
Yes, I was expect that there was an error since we do it one more time. Since I remove one from here, but not from here. Yes, this was expected, but this was not
Fail
so
again.
not so expected. Okay. Okay. Okay, when I in rush, I do the bad things and it doesn't work.
Take your banana.
Yes. So we want to start if we have 4 elements, 5 elements and 4 rotation. We want to start with the last element and put it to new array. So it will be exactly like this. So we don't need to do -1 here. And when we put the last element, then we increase the I by 1, which will be 5. So we will put the first element and we will do this until we put the last element. So right now it should work. No? No. Sorry. I have no idea why I do this -1, so okay. Always when I'm in hurry I do some stupid mistakes, but okay. So the count is the same variable, so it doesn't change. The last index will be, we have 5 elements and our count of rotation is 4. So we have 9. 9. And we go
9.
and we go from the I equal to count, and our count is 4. So we go from 4 to 9. And every time we get what is left from the division. So it will be generally like 4, 1, 2, 3, 4. It will be 5. The first element is 5. But okay, it will be like this one. This one will be correct. So it's index of array. We got the last index of array. Then instead of 5, since we get what is dividing for the element's length, which is 5, we got 0 here, then 1, then 2, then 3. So we do every operation like one time. Is it clean or need some more explanation?
Well, a little bit clear for me.
Okay, so let's calculate our space complexity now. We have new array, which is equivalent to our initial array, to elements array. So it will be like ON, whereas elements length. And we don't use anything else, just one variable that not structure, but just one variable. So space complexity will increase from O1 to ON. But time complexity here, again, we have one here, we have one here, we have ON for the cycle itself, because in worst case it's equal to the size of array, to the not to the size of array, since we do it less times, but anyway, no, it's always equal to the size of array, sorry, always equal, since we move every element once. And for push operation we have one, since adding last element to array is like very cheap operation, so it's easy. So we move our time complexity to ON, which is nice. So, but not for every task it useful to optimize it that way, because sometimes you can be fine with the n square, but not fine with additional memory consumptions. It depends. Sometimes you fine with much more memory consumption and not fine with CPU usage and so on. So you can like choose what you want, what is more optimal, and so on. So that's all for today. I think we solve like good task, learn something new, and optimize our algorithm.
And eat some bananas.
And eat some bananas. So thank you for watching. See you tomorrow.
Thank you for talking with us. Thank you for explanation in a deep ocean of programming.